This is Geometry, Chapter 4, Section 2, in which we will study angles of triangles and how those angles are related to each other. And we'll start off right away with our very first theorem of the chapter, Theorem 4.1, the triangle angle sum theorem. Basic idea here is that the angles in the triangle add up to 180. And we're going to use that tons this chapter and the rest of the year. We're going to keep coming back to the idea that triangles add up to 180. So let's find the measures of some angles. We have a triangle here, triangle ABC. And we know a few angles in there. And our job is to figure out angle 1, angle 2, and angle 3. Okay. Angle 3 is the easiest one to find because it's in this triangle, triangle BDC, and we know 2 of the 3 angles inside that triangle. So if we take 180 and subtract the 2 angles we know, we can find out that angle 3 is equal to 52. Now angle 2 we could figure out without even knowing the triangle angle sum theorem, because angle 2 and this 57-degree angle together make a linear pair. So when I subtract those, 180 minus the 57, I get 123 for angle 2. Well, now that I know angle 2 and I know this 28-degree angle, I can use the triangle angle sum theorem for triangle BAD. Angle 1 is 180 minus the 28 minus the 123 we just found. Tells us that angle 1 is 29 degrees. Now, another kind of angle that we need to talk about is called an exterior angle. You'll probably hear me say external angle. I use the 2 words interchangeably. But the idea is we're going to take one of the 3 sides of a triangle and we're going to extend it. Now when we extend that side, we form this exterior angle. Now whenever you have an exterior angle, that means you also have 2 remote interior angles. They're angles inside the triangle that are not next to this exterior angle. So they're over here away from the exterior angle. That's what the word remote means, away from. And those angles have a special relationship. And in fact, it's so special they made a theorem out of it, Theorem 4.2, the exterior angle theorem. Says that the exterior angle of a triangle is equal to the sum of the 2 remote interiors. So this angle out here is equal to these 2 added together. Now we're going to prove this theorem using a different type of proof. We've already met 2 kinds of proofs. We've met the 2-column and we've met the paragraph. And now we're going to have a third one, which is called a flow proof. Okay. And the idea of a flow proof is instead of writing everything in neat columns or in complete sentences, we use boxes and arrows to show how the argument works. We put our statements inside boxes, and then we put the reasons outside the box, usually beneath it or beside it. And then we draw arrows to show how things are connecting together. Sounds a little funky. It is a little funky. But you'll see what it looks like here on the next page. So we're going to prove theorem 4.2, the exterior angle theorem. So what we're given is we have a triangle ABC. And our job is to prove that angle 4 is equal to the sum of angle 1 plus angle 2. And we can't use 4.2 to prove that. You can't use the theorem itself to prove itself. So we'll start with what we know is given. We know that we have a triangle ABC. That's the given information. Now, what do we know about triangles, and particularly about the angles? We know they add up to 180. So angle 1 plus angle 2 plus angle 3 equals 180. And notice beneath that I put triangle angle sum theorem to show what my reason was. You could have theorem 4.1 if you wanted to. Now, I can see an angle 1 plus angle 2 forming here. I also need to talk about angle 4 somewhere. Well, I know angle 3 and angle 4 make a linear pair, and linear pairs are equal to 180. So I can put measure of angle 3 plus measure of angle 4 equals 180, because a linear pair equals 180. I could have also said linear pair theorem. Okay, or I could have looked up the number, whichever number it is. Now, I want you to consider this. I've got some stuff equals 180, and some other stuff also equals 180. So by doing a little bit of substitution, or I said transitive here, but you could call it substitution, I'm able to combine the two statements into one. I took this 180 out, and I put this stuff here, measure angle 3 plus measure angle 4, in its place. So notice I have two arrows leading to that statement because they came from here, and it also came from here. The two combined together to make one statement. Now this looks a lot like what I want. I just need to get these angle 3's out of the way. And the way to do that is by subtraction. So that's what a flow proof looks like. If they tell you a specific style of proof to use, you have to use that style. But if they don't, remember you have the choice. You can pick paragraph, you can pick 2-column, you can pick this, flow proof. Whichever one you like the best, or dislike the least. Now that we've got that theorem proven, we can apply it. We know we're looking at a triangle here, and we've extended one of the sides, so we're talking about an exterior angle, JKM, and we've got the two interior angles, angle M and angle L. So we can write an equation based on that theorem. This external angle here, 2y minus 15, is equal to y plus 50. Subtract the y over, add the 15 over, and we get y equals 65. And now we'll just plug that in. 2 times 65 is 130 minus the 15 here gives us 115 for that angle. Okay. One last idea we need to talk about is the idea of something called a corollary. Corollary is just a fancy name for a theorem, but it's a particular type of theorem in which the proof of this theorem comes directly from having another theorem handy. And I know it sounds kind of weird. It's really more a distinction that mathematicians make than anything else. For our purposes, the only difference in a corollary and a theorem is the name they give it. There are distinctions, but they're not that important to what we're doing. So our first two corollaries that we're going to run into come from the triangle angle sum theorem. Now, make sure when you're using these as reasons, you tell me that you're using the corollary, because remember, they number theorems the same way, they number postulates the same way. So if you just said 4.1, I wouldn't know which of the three things you're talking about. So make sure you tell me which one, that this is the corollary and not the theorem. So our first corollary, 4.1, the acute angles of a right triangle are complementary. Well, we know in a right triangle, we have one right angle. There's 180 degrees total, and one angle is 90 of those degrees. So that leaves 90 degrees for the other two angles to work with. Well, if two angles add up to 90, we call that complementary. So that's what this corollary is talking about. Our other corollary, and we hinted at this in the previous section, you can have at most one right angle or at most one obtuse angle in a triangle. Okay. Try to put two right angles in a triangle. Each of those two right angles is 90, so the two angles together make 180, and we have no degrees left for a third angle. So that doesn't work. It gets even worse if you try two obtuses, because you have two different angles, both of which are greater than 90. So you're already greater than 180 degrees with two angles. So the third one would have to be negative, and that doesn't work either. Now, be aware that you also can't have both a right and an obtuse. You could have one, you could have the other, but you can't have both. Okay. So we did the triangle angle sum theorem, that the angles add up to 180. We did the exterior angle theorem that says the exterior angle adds up to the sum of the two remote interiors. We learned about flow proofs, and we met some corollaries. And as always, if you had questions along the way, hopefully you jot those down, bring them in, and we will see you in class.